A brilliant spiral of stars, the Whirlpool Galaxy, spins in the void. Within its majestic arms lie secrets that defy our understanding of the cosmos. You are about to journey deep into this celestial whirlpool to uncover 30 of its strangest phenomena. By the end, you will possess a front row seat to the greatest unsolved mysteries in our galactic backyard. We will confront a supermassive black hole that flickers unpredictably and stellar clusters flung into the darkness at impossible speeds. What cosmic truth are you most curious to explore? At the very heart of the Whirlpool Galaxy, a cosmic beacon pulses with an impossible energy. This is not the galaxy's central supermassive black hole, but something else entirely, a point of light so brilliant in X-rays that it outshines the collective output of 1,000,000 suns. Astronomers call these objects ultra-luminous X-ray sources, or ULXs for short, and the one in the whirlpool is one of the most perplexing of all. Its power defies every known category of star or stellar remnant. A normal black hole, even one formed from a massive star, cannot account for such ferocious and steady brilliance. The mystery deepens with its strange behavior, flickering and flaring in unpredictable patterns. This is not the steady glow of a well-fed giant, but the sputtering candle of a cosmic engine we do not yet understand. So what could possibly produce such staggering amounts of energy? One compelling theory points to a long-sought cosmic missing link, an intermediate mass black hole. Imagine a black hole that is neither the small remnant of a dead star nor the supermassive titan at a galaxy's core, but something in between, with a mass of thousands of suns. Such an object would have the gravitational pull to power the intense X-rays we observe. Another, even more exotic, possibility is that we are witnessing a unique type of pulsar, a rapidly spinning neutron star. If this pulsar possesses a magnetic field of unimaginable strength, it could theoretically focus its energy into narrow, incredibly powerful beams that appear as an ultra-luminous source from our distant vantage point. Both ideas challenge the very foundations of high-energy astrophysics, forcing us to reconsider what is possible in the universe. The existence of this single, brilliant point of light raises a profound question: how can something so small and seemingly isolated rival the power of an entire galaxy's core? This brilliant X-ray source is not the only rebel in the whirlpool. Far out in one of its spiral arms lies the ghost of a star that died in a way we are still struggling to comprehend. Astronomers know it as SNR1, a supernova remnant that should be a nearly perfect sphere of expanding debris, a textbook example of a stellar explosion. Yet it is anything but. Its form is twisted and lopsided, a shattered bubble of gas stretching into the void at an uneven pace. The very elements forged in that final, cataclysmic blast are not spread evenly throughout this cloud. Instead, vast, unexpected pockets of oxygen and silicon cluster in strange, isolated regions, defying the clean, predictable models of how a star should end its life. Under normal circumstances, a supernova scatters its chemical legacy in a relatively uniform shell, like a perfectly mixed cake batter, but SNR1 is a cosmic kitchen disaster with all the flour piled on one side and the sugar on the other. This bizarre distribution forces a difficult question: what kind of stellar death could create such a chemical and structural mess? One possibility is that the progenitor star was an exotic type, perhaps a pair of stars so close they merged just before the explosion, creating a chaotic and lopsided detonation. Another theory suggests the expanding shockwave did not hit empty space, but instead plowed into a dense, pre-existing cloud of interstellar material, a cosmic wall that reshaped the blast and stirred the elemental pot. Each explanation points to a far more complex and violent stellar life cycle than we once believed. The echoes of that ancient explosion are still ringing, carrying a message we are only just beginning to decode. This lopsided stellar wreck is not the only gravitational oddity within the whirlpool. The galaxy's grand rotation holds a deeper, more pervasive mystery, one that involves the very fabric of its existence. As astronomers meticulously chart the speeds of stars and gas clouds swirling within its spiral arms, they find a puzzle that cannot be explained by the visible matter alone. The outer regions are spinning far too fast. According to the laws of gravity, these distant stars should be moving more slowly, like planets on the outer edges of a solar system. Instead, they race along as if pulled by an unseen hand, suggesting the presence of a massive, invisible halo of dark matter enveloping the entire galaxy. This dark matter provides the extra gravitational glue that keeps the galaxy from flying apart, yet here, the whirlpool defies expectations once more. When scientists measure this effect, and combine it with observations of how the galaxy's gravity bends light from objects behind it, a discrepancy emerges. The dark matter halo appears strangely configured. It is either far clumpier than the smooth, diffuse cloud that models predict, or it is significantly less massive than it should be for a galaxy of the whirlpool's size and type. It is as if you weighed a person by their shadow and their footprint, only to get two completely different results. This is not a minor accounting error, it is a fundamental challenge to our understanding of how galaxies form and what they are truly made of. Could our standard model of cosmology, which has been so successful on the largest scales, be missing a crucial piece of physics when applied to individual galaxies like this one? Or is the dark matter itself more complex and dynamic than we ever imagined, capable of behaving in ways that leave a contradictory signature? The whirlpool's silent, invisible halo may be the key to unlocking the nature of the universe's most dominant, yet most elusive, component. Even the invisible grip of dark matter cannot hold everything within the whirlpool's beautiful spiral. Scattered across the darkness beyond its main disk are brilliant, young families of stars moving at impossible speeds. These are runaway star clusters, entire cosmic communities flung out from the galaxy as if by some colossal, unseen hand. They are not drifting gently away, but racing into the intergalactic void at velocities so high they defy simple explanation. Each of these clusters contains the mass of thousands, sometimes millions, of suns, all born together in a single, dense nursery. To set such a massive object in motion requires a force of almost unimaginable power. So what cosmic event could possibly kick an entire city of stars out of its galactic home? One leading theory points to a gravitational slingshot, a celestial game of pinball on a galactic scale. During a close encounter with another galaxy, perhaps the small companion seen brushing past the whirlpool today, the complex gravitational tides could have whipped these clusters around and launched them on their escape trajectories. Think of it like a spacecraft using a planet's gravity to gain speed, but on a scale involving billions of stars. Another, more violent, possibility is that the cluster's own violent births sealed their fate. If a cluster forms in a particularly dense and unstable cloud of gas, the combined stellar winds and supernova explosions from its most massive stars could act like a cosmic bomb, explosively disrupting the very cloud that gave it life. This sudden asymmetrical push could literally blow the entire cluster clean out of the galactic disk. Both scenarios paint a picture of a galaxy far more dynamic and chaotic than its serene appearance suggests, a place where stellar communities can be born and then immediately exiled into the cold, vast emptiness between galaxies. What does the existence of these cosmic refugees tell us about the whirlpool's turbulent past, and what future awaits them as they travel, alone, through the eternal night? While these runaway star clusters flee the galaxy, other strange objects are hiding in plain sight, revealed only by the heat they radiate. Deep within the whirlpool's dusty spiral arms, powerful infrared telescopes have pinpointed brilliant, point-like sources of light that simply do not fit any known category. They glow intensely with the warmth of hidden cosmic engines, yet they have no clear counterpart in visible light, radio waves, or X-rays. They are not ordinary stars, they are not distant background galaxies, and they are not the remnants of supernova explosions. They are unidentified infrared objects, enigmatic beacons that challenge our catalog of celestial phenomena. So what could they be? One of the most compelling explanations is that we are witnessing the violent birth of massive stars, so deeply cocooned within thick, dark clouds of gas and dust that not a single glimmer of their visible light can escape. From our distant viewpoint, we only see the heat, the infrared glow from the surrounding material being warmed by the newborn stellar inferno within. It is like seeing the light from a lantern shining through a thick, woolen blanket. You know the source is there, but its true nature is completely obscured. Another possibility is that these are extremely young planetary systems in their earliest, most chaotic stages, where the central star has just ignited and is rapidly heating a vast, swirling disk of planet-forming material, causing it to shine brilliantly in the infrared spectrum. Yet, the sheer intensity of some of these objects pushes the boundaries of even these dramatic explanations. This has led to more speculative, though far less probable, ideas. Some scientists have wondered if we could be seeing the waste heat from unimaginably vast constructions, hypothetical megastructures built by an advanced civilization to harness the total energy output of a star. While this is an intriguing thought, it remains firmly in the realm of last resort speculation, as natural astrophysical processes are almost always the answer. The true nature of these mysterious infrared dots forces us to confront the limits of our observation, reminding us that even in a galaxy we can see in stunning detail, profound secrets still lurk behind the simplest veil of cosmic dust. These phantom arms glow with a faint, ethereal light, visible only in the specific red hue of hydrogen gas. They are not part of the galaxy's grand, star-filled design, but rather pale echoes weaving between the bright spiral arms like cosmic cobwebs. Their very existence suggests a turbulent history. One compelling explanation is that we are seeing the ghostly aftermath of a long-past meal, the tidal debris left behind after the whirlpool consumed a much smaller companion galaxy. The gravitational forces of that ancient encounter would have stretched the victim apart, scattering its stars and gas into these faint, lingering streams that now orbit out of sync with the primary structure. Another possibility is that these are not remnants at all, but the result of the galaxy's own internal rhythm. Spiral arms are often thought of as density waves, like cosmic traffic jams moving through the disk of stars and gas. It is possible that a secondary, weaker wave is propagating through the whirlpool, one that compresses gas just enough to make it glow without triggering the massive star formation that lights up the main arms. This would create a subtle, ghostly counterpart to the brilliant spiral we see. Imagine the wake of a boat spreading out in complex, overlapping patterns on the water. The whirlpool's majestic arms are the primary wake, while these ghost arms are the fainter, secondary ripples, a testament to the complex gravitational forces churning within the galactic disk. Whether they are the scars of a galactic collision or the signature of a hidden galactic heartbeat, these phantom structures remind us that a galaxy is not a static painting, but a dynamic, ever-changing system, with its past and its present written in light and shadow for those who know how to look. Even the space between the stars and the Whirlpool Galaxy is seething with a strange and unexpected energy. A vast, hot atmosphere, a galactic corona of superheated gas, envelopes its entire disk, and this plasma is a profound mystery in itself. It glows faintly in X-rays, revealing a temperature of millions of degrees, a level of heat so extreme it defies our best explanations. We know of two primary cosmic furnaces that should heat this gas: the collective winds from countless stars and the shockwaves from supernova explosions. Yet when astronomers add up the energy from all these sources, the total falls dramatically short. It is as if we were trying to heat an entire ocean with a few thousand campfires. The math simply does not work. An unknown and powerful energy source must be pumping heat into this galactic atmosphere, but its identity remains one of the galaxy's most persistent secrets. So where is this immense, hidden power coming from? One possibility lies with the very magnetic fields that weave through the galaxy. Like immense, invisible ropes tangled by the galaxy's rotation, these fields can suddenly snap and reconnect, releasing colossal bursts of energy in a process known as nanoflares. While each individual event might be small, their combined effect could be enough to cook the corona to its observed ferocious temperatures. Another, more dramatic, theory points back to the supermassive black hole at the galaxy's heart. Even in a quiet state, it may be releasing vast bubbles of energy that rise through the galactic disk, gently but persistently heating the halo of gas from the inside out. This coronal heating problem is not just a local accounting error. It challenges our fundamental understanding of energy flow within a spiral galaxy. It forces us to ask what other cosmic engines, completely invisible to our current telescopes, are humming away in the darkness, governing the life and death of the material between the stars. The galaxy's hot corona is not the only feature that defies a perfect, symmetrical shape. When we map the whirlpool not in starlight, but in the faint radio waves emitted by neutral hydrogen gas, its true, sprawling form is revealed, and it is profoundly lopsided. This basic building block of stars is not spread evenly around the galactic disk. Instead, one side of the galaxy appears stretched and drawn out, as if a giant hand had pulled a vast, gaseous tide away from the main body. This is not a small imperfection, it is a fundamental asymmetry in the galaxy's structure. So what cosmic force could twist an entire galaxy's gas reservoir out of shape? The most compelling suspect is the whirlpool's own companion, the smaller galaxy known as NGC 5195. For millions of years, this smaller galaxy has been engaged in a slow, gravitational dance with its larger partner, swinging close and then pulling away. During one of these close passes, its gravity would have acted like a powerful magnet, pulling on the whirlpool's diffuse outer hydrogen gas. Just as the moon's gravity tugs on Earth's oceans to create tides, the companion galaxy's pull would have drawn a colossal tide of gas out into the void. Even as the smaller galaxy continues its orbit, this stretched-out arm of gas has not had time to settle back into a symmetrical halo. It remains as a lasting imprint of that gravitational encounter, a fossil record of a past close call written in atomic hydrogen. This lopsided distribution has profound consequences. It means the raw material for future generations of stars is not equally available across the galaxy. One side is gas-rich, potentially poised for more active star formation, while the other is comparatively depleted. This celestial imbalance forces us to see galaxies not as isolated islands, but as deeply social entities whose structures and futures are permanently shaped by their gravitational interactions with their neighbors. The whirlpool's beautiful spiral may be the face it shows the universe, but its skewed hydrogen map is the lingering evidence of a dramatic and ongoing relationship. This imbalance in galactic gas finds a strange parallel in the hunt for a specific class of cosmic predator within the whirlpool. Across its many ancient, dense globular clusters, astronomers have meticulously searched for intermediate mass black holes, the very objects thought to power the galaxy's ultra-luminous X-ray sources. The result of this search is not a discovery, but a profound and puzzling absence. According to our best theories, these massive spherical collections of stars should be ideal nurseries for mid-sized black holes. The logic seems sound. Within such a crowded stellar environment, smaller black holes should merge and gravitate toward the cluster's center, accumulating over billions of years to form a single, more massive object. Yet, despite intense scrutiny, the Whirlpool's globular clusters appear to be missing their central predators. The expected gravitational signatures, the telltale swift orbital dance of stars around an unseen, massive center, are simply not there in most cases. This is not a matter of a single missing object, it is a systematic absence across numerous clusters. So where did they all go? One startling possibility is that the black holes never get a chance to settle in. The violent dynamics within a dense cluster can act like a cosmic catapult. When black holes interact through complex gravitational dances, the lightest one in a pair can be flung out of the cluster entirely at tremendous speed, a process known as gravitational recoil. Over the eons, this could have systematically ejected nearly every intermediate mass black hole from its home, banishing them to wander the dark spaces between the stars. Another, more subtle, explanation is that the conditions for their formation were just never right. Perhaps the clusters themselves formed in a way that prevented the necessary buildup of mass at their cores, or maybe the black holes that did form were simply not massive enough to hold their position and were instead pushed to the outskirts by the collective gravitational push of the countless stars. This missing population forces a difficult rethink of stellar evolution in crowded environments. Are our models of how black holes grow and interact fundamentally flawed? Or does the Whirlpool Galaxy possess a unique history that prevented these middleweights from taking root? The silence from its ancient star clusters is, in its own way, as loud and telling as any brilliant X-ray beacon. The hunt for unseen black holes is mirrored by the hidden magnetic forces woven through the Whirlpool's spiral arms. These are not the simple, orderly fields of a bar magnet, but vast, cosmic filaments of energy that thread between the stars. Recent observations have revealed a deep incongruity in areas of the galaxy that are quiet and dark, where new stars have not yet ignited. The magnetic field is strangely strong and highly organized. This defies our basic expectations, as the turbulent energy from stellar winds and supernova explosions is what we thought amplified and ordered these fields. It is like finding a powerful, perfectly tuned engine humming inside a sealed and silent room with no apparent power source. So what cosmic process is generating this invisible structure in the emptiness? One theory points to a slow, patient mechanism known as the dynamo effect. The gentle, differential rotation of the entire galactic disk itself could be acting like a gigantic, slow-motion generator. Over millions of years, this rotation could stretch and wind weak, primordial magnetic fields, twisting them into the strong, coherent patterns we detect. Another possibility involves the gravitational influence of the galaxy's dark matter halo. While dark matter does not interact with magnetic fields directly, its dominant gravitational pull shapes the flow of ordinary gas. As this gas slowly circulates, driven by the dark matter's gravity, it could be dragging the magnetic field lines along with it, organizing and amplifying them in regions that otherwise appear dormant. These magnetic structures are far more than a cosmic curiosity. They are active architects of the galaxy's future. A strong, ordered magnetic field exerts pressure on the surrounding gas, preventing it from collapsing under its own gravity to form new stars. This means the very forces that are invisible to our eyes could be responsible for keeping entire sections of the whirlpool in a state of quiet suspension, effectively putting a pause on star formation. The galaxy's beautiful spiral may not just be a product of gravity and gas, but also of this pervasive, magnetic handwriting etched across the cosmos. These invisible magnetic fields are not the only fleeting phenomena in the whirlpool. The galaxy has produced sudden, brilliant radio whispers that appear out of nowhere, only to fade back into silence within months. These are transient radio sources, and their brief, powerful lives present a new kind of mystery. Unlike the steady radio hum of a distant galaxy or the predictable pulse of a pulsar, these signals flare into existence, burn with incredible intensity, and then vanish, often never to be seen again. Catching them is a race against time, a cosmic game of hide and seek where the hider does not play by any rules we fully understand. So what natural event could unleash such a powerful, yet temporary, burst of radio energy? One strong candidate is a type of stellar cataclysm involving a dense, compact object like a neutron star or a black hole. Imagine a microquasar, a small-scale version of the violent quasars found in galactic cores. In this scenario, a stellar mass black hole pulls material from a companion star, forming a superheated disk of gas. This disk can become unstable, launching colossal jets of plasma at near light speed. When these jets interact with the surrounding interstellar medium, they can generate a brilliant, short-lived flash of radio waves that we see as a transient source. Another possibility points to an incredibly rare type of stellar flare. Some stars, particularly faint, cool dwarfs, are capable of producing superflares, eruptions of energy that make our sun's largest solar flares look like a tiny spark. A single, cataclysmic magnetic reconnection event on such a star could, in theory, release a radio burst powerful enough to be detected across the intergalactic gulf. And then, of course, there is the distant, speculative possibility that such a transient, targeted signal could be something else entirely, a beacon or a broadcast. Yet the overwhelming likelihood is that we are witnessing the death throes of a star or the violent hiccup of a cosmic particle accelerator, natural events so extreme and so brief that we are only just beginning to catalog their variety. Each vanishing radio source is a reminder of a dynamic, violent universe, one where the most dramatic events are often those that leave no lasting trace. Far from the galaxy's bustling spiral arms, a splash of brilliant blue defies all expectations. Astronomers call this region the blue blob, an isolated pocket of stars that shines with the intense, hot light of youth. These are not the ancient reddened suns you would expect to find in the galactic backwaters, but a stellar nursery that seems to have ignited in the middle of nowhere, far from the dense gas clouds that normally birth new stars. Its very existence is a geographical puzzle, a vibrant city of young stars built in a cosmic desert. So how did this blue oasis come to be? One compelling theory suggests we are not looking at a native part of the whirlpool at all, but the captured heart of a devoured dwarf galaxy. In this scenario, the whirlpool's immense gravity long ago tore apart a smaller companion, scattering most of its stars. The dwarf's dense core, however, may have survived the ordeal relatively intact, its own reservoir of gas collapsing under the shock of the encounter to ignite a final, glorious burst of star formation. What we see as the blue blob could be the lingering spark of that galactic cannibalism, the last bright ember of a galaxy that no longer exists. Another, equally fascinating, possibility is that the blob is a homegrown phenomenon, a testament to the galaxy's hidden volatility. A massive, invisible cloud of hydrogen gas, perhaps itself a tidal remnant from a past encounter, could have been drifting through the galactic halo for eons. When this cloud finally plummeted back down into the whirlpool's disk, the impact would have been colossal. The resulting shockwave would have compressed the gas violently, triggering a firestorm of star formation in a location that was previously serene and empty. It would be like a single torrential rainstorm causing a desert to erupt in a field of flowers. This blue blob forces us to reconsider the very map of a galaxy, reminding us that star formation is not confined to neat, predictable spiral arms. It can ignite in the most isolated voids, a sudden flash of cosmic creation written in the unmistakable color of stellar youth. Even the most energetic events in the Whirlpool Galaxy leave behind ghostly echoes. Extending far above and below its starry disk are colossal, faint structures known as gamma-ray bubbles. These are not made of gas or dust, but are vast regions of space glowing with the most powerful form of light in the universe, gamma radiation. They form a mysterious, hourglass-like shape that envelops the entire galactic core, a testament to some ancient, unimaginable release of energy. We see similar structures in our own Milky Way, but the ones in the Whirlpool offer a clearer view, a chance to understand their violent birth. So what cosmic engine could possibly inflate such massive, energetic balloons? The prime suspect is the supermassive black hole at the galaxy's center. While it appears quiet now, it may have been a raging quasar in the distant past. During an active phase, it would have devoured vast amounts of material, and in the process, it could have blasted out two opposing jets of plasma and radiation at nearly the speed of light. These jets, punching through the galactic halo, would have carved out cavities and filled them with high-energy particles, creating the very bubbles we detect today. It would be like a silent volcano whose massive eruption shaped the entire landscape millions of years ago, but there is another, equally dramatic, possibility. A period of incredibly intense star formation, a so-called starburst event, could have been the trigger. If thousands of massive stars were born and then died in rapid succession in the galactic center, their combined supernova explosions would have created a continuous, powerful wind. This galactic hurricane would have blown the surrounding gas outward, creating a bubble and accelerating particles to the energies needed to produce gamma rays. The lingering glow we see would be the fading heat from that ancient stellar frenzy, whether powered by the galaxy's central monster or by a firestorm of stellar births and deaths. These gamma-ray bubbles are a permanent scar. They reveal that the Whirlpool's serene beauty is a mask, hiding a history of colossal, galaxy-shaping violence that continues to reverberate across the eons. This cosmic dust is not a uniform veil, but a landscape of deep shadows and strange geometry. Cutting across the galaxy's brilliant core is a particularly prominent dark lane, a thick, twisted river of cosmic soot that seems to swallow the light from the stars behind it. It is far more substantial and contorted than the typical, wispy dust clouds found throughout the spiral arms. Its lopsided structure suggests a history far more turbulent than a simple, quiet drift through space. To understand the story written in this darkness, astronomers turn to a subtle technique known as polarimetry, which measures the alignment, or polarization, of the light that filters through the dust. The tiny, needle-like grains of silicate and carbon that make up the dust tend to align themselves with any magnetic fields present, like countless compasses all pointing the same way. When starlight passes through, it becomes polarized, its light waves oscillating in a preferred direction. By mapping this polarization across the dark lane, scientists can trace the invisible magnetic architecture woven through the cloud. The resulting picture is one of chaos. The magnetic fields are not smooth and orderly, but are tangled and twisted into complex knots. This magnetic turmoil points directly to a violent past. The dust lane is not a static structure, it is a dynamic river, likely funneling material inward toward the galaxy's core. As this immense flow of gas and dust surges forward, it collides with itself and with the surrounding interstellar medium, creating shockwaves and turbulence that scramble the magnetic fields. This constant churning and compression could easily explain why the lane is so unusually thick and opaque, as the dust grains are constantly being stirred up and packed together. The gravitational influence of the Whirlpool's companion galaxy likely plays a crucial role in this drama. Its repeated close passes would have sent powerful gravitational ripples through the larger galaxy, disturbing the orderly flow of gas and triggering the very instabilities that cause such dense, lopsided dust lanes to form and persist. This dark, dusty scar is more than just an obstruction. It is a fossil record of the continuous, violent struggle between gravity, magnetism, and motion, a hidden channel through which the galaxy is still feeding its own hidden heart. Woven into one of the Whirlpool's grand spiral arms is a celestial necklace of unparalleled perfection. This is the string of pearls, a straight, flawless line of brilliant star clusters, each one a massive family of young, blue stars, all arranged with a geometric precision that seems to defy the chaotic nature of the cosmos. Chance alone could not have placed these stellar nurseries in such a perfect, linear formation. Their alignment points to a single, sweeping event that ignited star birth simultaneously across a vast distance. So what cosmic force could draw a straight line of fire across the galaxy? One of the most compelling theories involves a triggered chain reaction. Imagine a massive shockwave, like a sonic boom on an interstellar scale, plowing through a long, dormant filament of molecular gas. This shockwave could have been the result of a nearby supernova explosion, or perhaps the powerful stellar winds from a previous generation of massive stars. As the wave compressed the gas cloud, it would have reached the critical density for star formation at multiple points along its length at nearly the same instant. It is like a trail of gunpowder being lit at one end, with the flame racing along the fuse and creating a series of brilliant, evenly spaced flashes. The result is the string of pearls we observe today, a fossilized record of a single, propagating wave of creation. An alternative explanation suggests the pearls formed from the cloud's own slow collapse. The original molecular cloud may have been a vast, sinewy structure, a cosmic serpent of gas and dust. Its own internal gravity, pulling it inward, could have caused it to fragment at regular intervals, much like a stream of water breaking into distinct droplets. Each of these dense knots would then have collapsed to form a massive star cluster, naturally lining up along the spine of their parent filament. Whether sparked by an external shock or seeded by its own slow death, this structure reveals a hidden order within the apparent chaos of galactic evolution. It shows us that star formation is not always a random scattering of seeds, but can be a deliberate, patterned process orchestrated by the fundamental laws of physics on a truly breathtaking scale. Even the galaxy's faint outer light holds a secret signature. Surrounding the Whirlpool's bright disk is an enormous, structured halo glowing in ultraviolet light, far more brilliant and complex than anyone predicted. This is not the soft glow of the galaxy's main body, but a vast, energetic aura that stretches deep into the void. For such intense ultraviolet radiation to exist, it must be produced by an immense population of incredibly hot stars, far from the familiar stellar nurseries of the spiral arms. These are not youthful blue giants, but ancient stars in their final, ferocious stages of life. We are likely seeing the collective output of countless white dwarfs, the exposed, searing hot cores of sun-like stars that have shed their outer layers. Each one is a stellar ember, blazing with surface temperatures in the hundreds of thousands of degrees, pouring ultraviolet light into the galactic halo. But the sheer scale and structure of this glow suggest another, more dynamic source at work. The halo's intricate form hints that the Whirlpool is not an isolated system. It may be continuously feeding, siphoning a slow rain of pristine hydrogen gas from the intergalactic medium. As this cold gas falls into the galaxy's gravitational well, it could be shocking and heating up, or perhaps it is igniting a previously unseen, sparse population of new stars in the halo itself, stars that live fast, die young, and burn with an intense ultraviolet fury. This extended ultraviolet halo forces a dramatic shift in how we view a galaxy's life cycle. It suggests that a galaxy's true boundary is not a sharp edge, but a diffuse, energetic frontier, a place where the galaxy constantly interacts with and consumes the raw material of the cosmos. What other hidden stellar populations or silent flows of intergalactic gas are revealed only by this faint, ultraviolet whisper from the darkness? This subtle warp in the whirlpool's very skeleton offers a profound clue to its history. The galaxy does not spin as a single, flat plate. Instead, the inner disk of older stars is tilted ever so slightly against the outer disk of gas and dust. It is as if the galaxy's heart is turning on a different axis than its sprawling limbs. This misalignment is not obvious to the casual observer, but through precise measurements, astronomers have mapped this cosmic wobble. The outer gas disk, rich with the raw material for new stars, follows one plane, while the dense, stellar core follows another. This creates a gentle, galaxy-wide twist, a warping that speaks of deep, dynamic forces at work. So, what could have caused such a fundamental architectural flaw? One possibility is that we are seeing a fossil imprint from the galaxy's violent birth. Billions of years ago, as the whirlpool first coalesced from a vast cloud of primordial gas, it may have formed from multiple, smaller clouds that collided and merged. If these clouds were not spinning on the same plane, their union would have created a disk with a built-in twist, a relic of that chaotic initial construction. Another, more dynamic, explanation points to an ongoing gravitational conversation. The persistent tidal tug from its smaller companion galaxy could be slowly torquing the inner stellar disk, pulling it out of alignment with the more extensive and more easily influenced outer gas disk. Think of it like a spinning top that begins to wobble as an external force gently nudges it. The entire system is responding to a rhythm imposed from outside. This misalignment is far from a static feature. It is a snapshot of an ongoing process. The gravity of the inner stars and the dark matter halo constantly pulls on the outer gas, trying to force it into the same plane, while the gas's own momentum and the external pull of the companion galaxy fight to maintain the warp. This slow, cosmic struggle dictates the flow of gas and the future sites of star formation. The beautiful, flat spiral we see from afar is, in reality, a complex, three-dimensional structure, its slight warp a permanent record of the forces that built it and the neighbors that continue to shape its destiny. One of the whirlpool's ancient star clusters holds a fossilized secret that defies the very timeline of stellar life. This particular globular cluster appears, at first glance, to be exactly what astronomers call red and dead. Its population is dominated by ancient, cool, red stars, with no sign of the brilliant blue stars that signal recent birth. It should be a quiet retirement home for aging suns, a system that settled into a peaceful equilibrium billions of years ago. Yet, upon closer inspection, its stars tell a different story. Their motions are unexpectedly stirred up, showing the subtle fingerprints of recent dynamical activity. The stellar orbits are not perfectly relaxed and sorted by mass, as you would expect in a truly ancient, undisturbed system. It is as if this quiet, elderly community was recently shaken by a powerful, unseen event. So what could have stirred up this red and dead cluster? The most likely culprit is a close gravitational encounter, either with a massive molecular cloud or with the dense core of the galaxy itself. Such a flyby would have acted like a gravitational paddle, churning the cluster's interior and injecting new energy into the motions of its stars without triggering any new star formation. Another, more intriguing possibility involves the cluster's own hidden population of stellar remnants, a collection of neutron stars or black holes lurking unseen in the cluster's core, could have undergone a period of complex gravitational interactions, slingshotting each other around and transferring energy to the lighter, visible stars, effectively reheating the entire system. This cluster's quiet red appearance is a mask hiding a recent history of violent gravitational turmoil. It forces us to ask a deeper question: can a stellar system be both dynamically young and stellarly old at the same time? This single, seemingly dormant cluster challenges the simple idea that galaxies and their components age in a linear, predictable way, revealing instead a cosmos where even the oldest structures can be violently shaken back to life. Deep within the cold, dark nurseries of the Whirlpool's spiral arms, the very chemistry of star birth tells a strange and silent story. Astronomers analyzing the faint light from these molecular clouds have found a peculiar signature in the gas itself, an anomalous ratio of carbon monoxide isotopes. This might sound like an esoteric detail, but it is a fundamental chemical fingerprint. Carbon monoxide is one of the most common molecules in these stellar nurseries, and it comes in different forms or isotopes, with carbon-12 being the most abundant and carbon-13 being much rarer. In most galaxies, including our own, the ratio between these two forms in similar clouds is relatively consistent, but here, in specific regions of the Whirlpool, that ratio is skewed. There is either too much of the rare carbon-13 or too little of the common carbon-12. This imbalance points to a history written not in light, but in atomic nuclei. So what could cause such a specific chemical anomaly? One possibility is that these clouds were seeded by a unique generation of stars. Massive stars forge heavy elements in their cores and then scatter them into space when they explode as supernova. The specific mix of elements they release depends on their initial mass. A cluster of particularly massive stars, all exploding in a localized region, could have enriched the surrounding gas with an unusual abundance of carbon-13, painting the next generation of clouds with this distinct isotopic brush. It is as if a specific neighborhood in the galaxy was fertilized by a single, dramatic event, leaving a chemical legacy that persists to this day. Another, more subtle, explanation involves the very temperature and density of the clouds themselves. Chemical reactions favor different isotopes under different conditions. If these clouds have endured a history of being repeatedly compressed and heated by shockwaves from nearby stellar winds or supernova, the chemical reactions occurring on the surfaces of dust grains could have preferentially locked away carbon-12, leaving the gas enriched with the heavier carbon-13. This would mean the anomaly is not a relic of ancient stars, but a dynamic, ongoing process, a chemical cycle driven by the galaxy's own turbulent weather. Either way, this isotopic whisper forces us to listen more carefully. It suggests that the pathway to creating stars, and eventually planets, is not a uniform recipe across the cosmos. The Whirlpool Galaxy may be cooking with a slightly different set of ingredients, raising a profound question about the worlds that might be forming there. Could the fundamental building blocks of life, the carbon-based molecules, have a subtly different origin story in this swirling island of stars? Even the Titan at the galaxy's heart refuses to follow a predictable script. The supermassive black hole powering the Whirlpool's core is not a raging quasar, but it is far from silent. It flickers. This faint, low-level activity from the active galactic nucleus reveals itself in small, rapid fluctuations in brightness, a subtle sputtering that defies the more stable and predictable glow of other galactic cores. It is not consuming a steady, smooth river of matter, but rather seems to be feeding on a chaotic, clumpy diet. Picture a campfire sputtering and crackling as you toss on uneven pieces of wet wood. Some pieces ignite quickly with a bright flash, while others smolder and smoke. This is the kind of messy, inefficient feast happening on a cosmic scale. The accretion disk, the swirling maelstrom of superheated gas spiraling into the black hole's maw, must be a turbulent and fragmented environment. Instead of a uniform, glowing disk, it is likely a collection of dense gas clouds and sparse voids, each clump falling in at its own pace and producing its own brief, flaring signature of light. This flickering behavior is a crucial clue, telling us that the journey of matter into a black hole is far more complex than a simple, orderly spiral. It suggests that the fuel supply from the surrounding galaxy is unstable, perhaps delivered in irregular gusts by those twisted dust lanes and distorted magnetic fields we explored earlier. Why does this matter? Because this seemingly minor detail, this faint sputtering, holds the key to understanding the life cycle of a supermassive black hole. Its quiet, flickering state may be the most common mode of existence for these cosmic monsters, a long, slow feast between rare and violent outbursts. The whirlpool's heart does not beat with a steady rhythm, but with a faint, irregular pulse, a whisper about the chaotic nature of how the universe feeds its most enigmatic creatures. This faint river of ancient stars is a ghostly current flowing through the galaxy's outer halo. It is not a part of the whirlpool's main structure, but a separate, ethereal stream of suns, each one incredibly old and deficient in heavy elements. These metal-poor stars are cosmic relics, forged in the early universe before countless supernova explosions had seeded space with iron, silicon, and oxygen. Their very composition marks them as outsiders, immigrants from a much smaller, more primitive galaxy. The stream's graceful, coherent arc is the final death spiral of that lost dwarf galaxy, a fossilized record of a meal consumed billions of years ago. As the whirlpool's immense gravity captured its smaller neighbor, it did not swallow it whole. Instead, it began to slowly unravel it, stretching the dwarf galaxy over eons into a long, stellar ribbon that now wraps around the larger galaxy like a faint, cosmic serpent. The fact that this stream remains so clearly defined today is a crucial clue. Its structure has not yet been blurred and mixed into the whirlpool's general halo, meaning this act of galactic cannibalism is a relatively recent event in cosmic terms, perhaps occurring within the last few billion years. This forces a dramatic revision of the whirlpool's history. We often picture galaxy growth as a slow, steady accumulation of gas, but this stellar river reveals a past punctuated by violent mergers. The serene spiral we admire is, in part, the product of a brutal conquest, its outer reaches still echoing with the gentle orbital motions of its vanquished foe. What other faint streams of ancient stars might be woven through the darkness, silently testifying to the whirlpool's long and violent appetite? The Whirlpool Galaxy is caught in a cosmic identity crisis. Despite its vibrant, star-filled arms, it is officially classified as a Green Valley Galaxy, a term that places it in a strange transitional state between the blue, actively star-forming galaxies and the red, dead ones. This is a profound paradox. How can a galaxy that looks so alive be slowly, quietly dying? Its grand spiral arms are a brilliant blue from the light of young, massive stars, and its dust lanes are rich with the raw material for future generations. Yet, the overall rate of new star birth has begun to slow, as if a cosmic hand is gently turning down the thermostat on stellar creation. This Green Valley status is not about the color green, but a metaphorical middle ground, a long, slow sunset for a galactic ecosystem. So what immense force could be quenching the whirlpool's fiery creativity? One possibility lies within its own beautiful structure. The very process of building and maintaining such a perfect spiral may be sealing its fate. As the density waves that create the arms sweep through the disk, they efficiently funnel gas into the brilliant clusters we see, but this might be a feast that leads to a famine. The galaxy could be consuming its gas reserves too quickly, turning its raw material into stars at an unsustainable rate without a fresh influx of fuel. Another, more external, force is likely at play: the gravitational influence of its companion galaxy. Their ongoing dance may be subtly stripping away the whirlpool's vast, diffuse reservoir of hydrogen gas, the very fuel it needs to create new stars in the future. It is as if a thriving civilization is still building magnificent cities, but someone has quietly turned off the water supply to its farmlands. The eventual outcome is a slow but inevitable transition. The brilliant blue giants will burn out, and without new stars to take their place, the spiral arms will gradually fade to the red glow of longer-lived, cooler stars. The whirlpool's current beauty is a magnificent, but perhaps temporary, phase. This Green Valley paradox forces us to see galaxies not as static portraits, but as dynamic systems with life cycles, and it raises a haunting question: are we witnessing the peak of this galaxy's glory, or the beginning of its long, graceful decline into the red sequence? Even in the quiet deaths of its stars, the Whirlpool Galaxy refuses to be ordinary. Scattered among its aging stellar populations are planetary nebulae, the final, glowing shrouds of sun-like stars, and a handful of them shine with an impossible brilliance. These are not the faint, fleeting ghosts typically associated with a star's last breath, but colossal, radiant structures that outshine their counterparts by a significant margin. Their intense light, particularly in specific wavelengths like oxygen and helium, points to a far more violent and complex end than the standard stellar model allows. A typical planetary nebula forms when a single, dying star gently puffs off its outer layers, which are then illuminated by the hot, exposed core, but that simple, solitary death cannot explain the ferocious energy output of these anomalies. So what celestial drama could produce such a luminous farewell? One compelling explanation involves a cosmic partnership, a binary star system at the heart of the nebula. If the dying star has a companion, the gravitational dance between them can drastically alter the final act. As the primary star expands into a red giant, it can transfer mass onto its partner, or the companion's gravity can violently strip away the outer layers, funneling the ejected material into dense, confined shells and jets. This creates a far more efficient and energetic engine, heating the gas to extreme temperatures and causing it to glow with the unusual intensity we observe. It is the difference between a single candle flickering out and a controlled explosion of flash powder. Another possibility is that the progenitor stars themselves were chemical oddities. Born from clouds with an anomalous mix of elements, perhaps enriched by a nearby supernova long ago, these stars would have had a different internal structure and a different death. A star with a higher initial abundance of elements like carbon or oxygen burns its fuel differently, potentially leading to a more massive core and a far more energetic final expulsion. The brilliant nebula we see is then the final flash of a star that was never quite normal to begin with, its unique chemical birthright written in the light of its death. These unusually luminous planetary nebulae are more than just beautiful cosmic flowers, they are forensic evidence. They tell us that the death of a star is not always a solitary, peaceful event, but can be a turbulent process shaped by unseen companions or a unique ancestral legacy forever recorded in the glowing gas. This ring of fire is a cosmic blast zone of staggering proportions. Known as a superbubble, it is a vast, hollow sphere of million-degree gas, blown clear by the combined fury of stellar winds and supernova explosions. Its sheer size is what defies belief, a cavity so enormous it could swallow entire solar systems whole. To carve out such a void in the dense interstellar medium requires a sustained and concentrated release of energy, far beyond what a single star could ever produce. This is not the work of one titan, but of an entire dynasty of massive stars, all living and dying together in a terrifyingly short cosmic instant. Imagine a crowded neighborhood where every house simultaneously explodes, the combined shockwaves merging into a single, overwhelming blast that clears the entire area. This is the kind of coordinated stellar violence required to forge the Ring of Fire. Astronomers call such an event a starburst, a brief, frenzied period where star formation runs wild. Within a giant molecular cloud, a whole generation of massive stars can be born at nearly the same time. These stars live fast and die young, and over a few million years, their powerful winds begin to push against the surrounding gas, hollowing out a growing cavity. Then the most massive ones start to explode, one after another. Each supernova detonation injects more energy into the bubble, causing it to expand outward at tremendous speed. The ring we observe is the brilliant, glowing shock front where this expanding wall of hot gas slams into the colder, denser material of the galactic disk. The extreme energy output of this single structure forces us to reconsider the very nature of stellar societies. It reveals that stars are not always born in isolation, but can emerge in vast, synchronized families, their collective lives and deaths so intertwined that they reshape the galaxy itself. What does such a ferocious, localized burst of creation and destruction do to the surrounding spiral arm? Does it leave behind a fertile wasteland, enriched with the elements for new worlds, or a sterile desert, scoured clean of the gas needed for future stars? But even amidst these stellar explosions and brilliant bubbles, vast reservoirs of potential remain locked in silence. Drifting through the spiral arms are colossal clouds of molecular gas, detected by their faint radio whispers that show absolutely no signs of giving birth to stars. These are not just empty voids, they are dense, massive nurseries that have inexplicably closed their doors. Under normal conditions, such a concentration of cold hydrogen and dust should be collapsing under its own weight, fragmenting into glowing protostars. Yet here, the trigger has failed, so what invisible force is keeping these cosmic cradles from rocking? One possibility is that the clouds are simply too turbulent. Imagine trying to form a snowball in a hurricane. The fierce, chaotic internal motions of the gas create a persistent pressure that fights against the pull of gravity, preventing any single region from becoming dense enough to ignite. Another, more subtle inhibitor could be a surprisingly strong magnetic field frozen within the cloud. These invisible lines of force act like a skeleton, providing structural support that holds the cloud up against its own weight. To form a star, the gas must slowly slip across these magnetic field lines, a process that can take far longer than anyone anticipated. There is also the haunting possibility that these dark clouds are the aftermath of prior violence. A nearby supernova's shockwave might have compressed them in the past, but instead of triggering collapse, it may have only stirred them into a state of agitated stability, like a pond that has been disturbed and now cannot settle to form a clear ice. These silent, dark clouds are a profound cosmic paradox. They hold all the ingredients for creation, yet they remain frozen, challenging our most basic understanding of what it takes to light a new sun in the darkness. The galaxy's halo holds stars that move to a different rhythm, while the vast majority of stars in the Whirlpool's disk follow an orderly, circular dance around the galactic center. Astronomers have pinpointed suns in the outer halo that break this pattern entirely. Their trajectories, measured with extreme precision through astrometry, are chaotic and misaligned. Some plunge almost radially inward, others loop on wildly inclined orbits, and a few even seem to be moving against the galaxy's spin. This proper motion mismatch is a clear sign that these stars are not native to the Whirlpool. They are interlopers, cosmic immigrants captured from other galaxies. Their unique orbital paths are the final, fading signatures of ancient acts of galactic cannibalism. Each one tells the story of a smaller galaxy that ventured too close and was torn apart by the whirlpool's immense gravity. The stars we see today, moving against the flow, are the survivors of that disruption, still following the orbital instructions imprinted upon them by their original, long-vanished home. It is as if you were watching a vast river flow smoothly to the sea, only to notice a few powerful swimmers stubbornly fighting the current, each one a reminder of a different stream that once merged with this great waterway. This evidence of past mergers forces a dramatic shift in perspective. The Whirlpool Galaxy is not a solitary island universe that formed in isolation. It is a hybrid, a galactic melting pot whose outer reaches are a museum of conquests, displaying the captured relics of its violent history. What other secrets about the galaxy's formation are written in the rebellious paths of these ancient, wandering stars? This delicate element should not exist in these ancient stars. Lithium is the universe's most fragile light metal, easily torn apart in the nuclear furnaces of a stellar core. In a red giant, a star that has expanded in its old age, the deep interior convection should have carried any primordial lithium down into the inferno to be destroyed billions of years ago. Yet when astronomers point their spectroscopes at specific red giants in the whirlpool, they detect its faint, unmistakable spectral signature. It is like finding a perfect, frozen ice cube sitting in the heart of a blast furnace, a clear violation of everything we know about stellar chemistry. This is the lithium problem, and its presence in these aging stars points to a hidden process we have not yet accounted for. So how is this fragile element not only surviving, but perhaps even being created deep within these stellar seniors? One possibility is that we are witnessing the result of a deep and turbulent mixing process that standard stellar models do not include. The interior of a red giant may be far more chaotic than we thought, with currents that bring newly forged material up from layers just above the core. In these specific hot and dense regions, a rare nuclear reaction could be fusing helium atoms to form lithium, which is then quickly whisked to the surface by the very same currents before it can be destroyed. It is a stellar production line, manufacturing the element and delivering it to safety. Another, more exotic, theory involves a cosmic collision. A red giant could have recently consumed a small, rocky planet or a brown dwarf. The lithium-rich material from that destroyed world would then be stirred into the star's outer layers, contaminating its atmosphere and creating the anomalous signature we see. This would mean the lithium is not a product of the star itself, but the fossil of a planetary system it devoured. Both ideas force a dramatic revision of stellar interiors. The serene, layered onion model of a star might need to be replaced with a picture of a dynamic, churning cauldron where elements can be both created and preserved in ways we never anticipated. What other delicate secrets about the life and death of stars are written in this faint lithium line, a single note in the grand spectrum of the whirlpool? The galaxy's violent energy does not radiate evenly into the void. When mapped by gamma-ray telescopes, the whirlpool reveals a profound lopsidedness, with one of its majestic spiral arms glowing far brighter in the universe's most powerful light than the other. This is not a trick of perspective or a flaw in the data. It is a real and puzzling asymmetry in the distribution of high-energy gamma-ray photons. These photons are not produced by ordinary starlight. They are the signature of immense violence generated when subatomic particles, accelerated to nearly the speed of light, slam into the nuclei of atoms or into photons of starlight. The entire process is a cosmic relay race, starting with a powerful event like a supernova explosion. The blast wave from a dying star acts as a natural particle accelerator, boosting protons and electrons to fantastic energies, creating what we call cosmic rays. These high-energy particles then travel through space until they collide, and in that spectacular crash, they produce gamma rays. So, for one spiral arm to shine so much brighter in this extreme light, it must contain a significantly higher concentration of these cosmic ray factories. That particular arm is likely a supernova alley, a region where massive stars have been born, lived, and died in such rapid succession that the remnants of their explosions litter the landscape. Think of it as one side of the galaxy being a bustling industrial district, with factories running at full capacity, while the other side is a quieter suburb. The constant churn of stellar death in the brighter arm ensures a continuous and dense population of cosmic rays, leading to more frequent collisions and a more intense gamma-ray glow. This imbalance forces a deeper question about the galaxy's internal dynamics. Why would star formation, and consequently stellar death, be so heavily concentrated in one arm over the other? The answer may lie in the whirlpool's gravitational dance with its companion. The tidal forces from their interaction could have recently compressed that specific arm, triggering a more intense wave of star birth that has since led to a corresponding wave of star death. The brilliant asymmetrical gamma-ray glow is therefore more than just a snapshot of current violence. It is the lingering echo of a recent, galaxy-wide disturbance, a testament to how a celestial neighbor can dictate the rhythm of life and death across an entire spiral. Deep within the whirlpool's stellar nurseries, the cradles of future worlds are themselves objects of profound mystery. Astronomers have observed protoplanetary disks, those vast, spinning platters of gas and dust around infant stars that possess a staggering amount of raw material. These are not the modest, dusty disks we see in our own galactic neighborhood, but colossal, overstuffed reservoirs containing far more mass than our entire solar system. The sheer volume of material defies the typical models of how planetary systems are built. In a normal scenario, a disk like the one that formed our Sun contains just enough mass to create a family of planets. But here, the disks hold enough substance to forge dozens of Jupiters, or even something far larger. This surplus of raw material presents a fascinating puzzle. What kind of planetary systems will eventually emerge from such massive beginnings? One possibility is the birth of super-Jupiter planets, gas giants of such immense scale that they push the very definition of a planet to its limits. These behemoths would wield gravitational influence far beyond anything in our solar system, potentially dictating the orbits of all other worlds in their system. An even more extreme outcome is the formation of brown dwarfs right there within the disk. Brown dwarfs are often called failed stars, objects too massive to be planets, but not quite massive enough to ignite sustained hydrogen fusion in their cores. The idea that a protoplanetary disk could actually fragment and collapse to form one of these substellar objects alongside its central star is a radical departure from our standard picture of planet formation. It suggests that a single stellar nursery could give birth to a binary system, not of two stars, but of a star and a nearly star from the same swirling disk of material. How does a disk accumulate so much mass without collapsing prematurely or being blown away by the intense radiation from its newborn star? The answer may lie in the unique, dense environment of the whirlpool's spiral arms. Perhaps these disks form in exceptionally rich and sheltered pockets of gas, allowing them to feed for longer periods without disruption, or maybe the chemistry of the cloud itself, its specific mix of dust and ice, makes the material more resistant to being dispersed by stellar winds. These two massive disks are more than just curiosities, they are active experiments in planet formation, challenging our understanding of how common or rare our own solar system's architecture might be across the cosmos. What strange and giant worlds are taking shape right now within these overstocked celestial workshops? Even the grandest acts of creation in the Whirlpool Galaxy are not entirely its own. A profound and mysterious rhythm connects its stellar birth to that of its smaller companion, NGC 5195, when a wave of new star formation sweeps through one of the Whirlpool's spiral arms. A corresponding burst often ignites within the smaller galaxy, as if both are hearing the same cosmic drumbeat. This synchronization is deeply puzzling because the two galaxies are separated by tens of thousands of light years, a vast gulf of empty space. They are not physically touching, so how can the star-forming rhythm of one possibly dictate the rhythm of the other? The secret seems to lie in an invisible, galaxy-spanning connection. One possibility is a delicate bridge of cold hydrogen gas stretched between the two galaxies by their gravitational dance. As the Whirlpool experiences an internal wave of star formation, the resulting shock waves and stellar winds could travel along this gaseous filament like a pulse racing down a cosmic nerve. When this pulse of energy and pressure reaches the companion galaxy, it compresses the gas there, triggering a new round of star birth in near-perfect harmony with its larger partner. It is a celestial chain reaction operating on an immense scale. An even more subtle theory involves the shared halo of dark matter that envelops both galaxies. This invisible scaffold dictates how ordinary matter flows and collects. A disturbance in the dark matter distribution around the Whirlpool, perhaps caused by the same density wave that creates its spiral arms, could ripple through the entire system. This ripple would then influence the gas within the smaller companion, coaxing it to collapse and form stars at the same cosmic moment. This synchronized stellar birth reveals that galaxies bound by gravity do not evolve in isolation. They are partners in a slow, intricate dance, their fates intertwined by forces both visible and unseen. The Whirlpool and its companion are not just two independent islands of stars, but a single, coordinated system, breathing in and out to a rhythm we are only just beginning to perceive. From its flickering heart to its farthest stellar halo, the Whirlpool Galaxy is a living catalog of cosmic contradictions. We have journeyed past a supermassive black hole that feeds in chaotic fits, navigated lopsided supernova remnants, and traced the paths of runaway star clusters flung into the void. We have felt the heat of a mysterious corona, mapped its skewed hydrogen tides, and listened for the silent, missing black holes in its ancient globular clusters. Each phenomenon, from the tangled magnetic fields in quiet voids to the synchronized stellar birth with its companion galaxy, forces us to rewrite a page in the textbook of astrophysics. There is no single key that unlocks this galactic whirlpool, only a cascade of questions that challenge our understanding of dark matter, stellar life cycles, and the very forces that build and shape island universes. So, as this exploration ends, the greatest question now returns to you. Which of these 30 strange truths captured your imagination the most? Was it the ghostly stellar streams of ancient conquests, the brilliant blue blob of unexpected creation, or the faint lithium signature defying stellar death? Let us know your choice, and if you crave more journeys to the frontiers of cosmic mystery, be sure to subscribe for our next deep dive into the universe's greatest enigmas.